Hello, everyone. I'm just going to go ahead and pull up a tab of the stream to check audio and latency, and then we'll just go ahead and get started. All right, seems like there's, as typical, a decent amount of delay. Just going to click around a bit, you know, the typical, so I can just watch back in the stream and see how choppy it may or may not be. Oh yeah, it looks fine. Great. So I'll close out my window of the stream now. I'll be watching chat on and off through my OBS window. Um, and yeah, one more thing before I get started. As those of you who read the description and or my community post will know, this might not be as productive as the last stream. I was out in the heat for a good while this morning. I still feel a bit tired and I've got a bit of a headache from that, but you know, feeling better now that I got some food and water, and also I got a meningitis shot yesterday. So I have pretty limited movement in my right arm. I don't think that typing will be an issue, but I think if I do it for long enough, it may start to be. So I might have to take, you know, a break or two during the stream to just kind of chill, and possibly end stream early if it gets bad. But all that being said, I'm just going to go ahead and hop back into the code. So let's see where we were last time. I believe we were able to pick up pieces and place them anywhere that the player does not already have a piece. Now I would like to bring the currently selected piece up to a higher depth layer than the other ones. So let's go ahead and add that. All right, so we'll just start by saying z equals. Can't remember if a higher number is closer or further away from the camera. And then when we set the piece down, we will. Oh, it's not in z, it's depth. That's right. I have a custom z variable in the other project that I'm working on, because mild spoiler, there is a bit of limited 3D in that game. You may or may not see some of that on stream in the future when I develop that game's combat engine. Undecided if I'm going to do that in a separate project or in the same project. So anyways, I think the depth should defaultly be 0, but just in case. Actually, we might want it to be depth equals 1 because the tile layer is at 0, I think. Oh, no, the tile layer is at 100. Okay, which also tells me that I'm doing this slightly wrong because -1 would be closer to the screen. So all that fixed, let's just give it a try here. All right, looks all good. So I think next thing we do can either be to expand the legality checker or to implement um, turns. I think because turns will be quicker, I'll start off with that, kind of get me into the groove of it before I go into the more complicated things. So let's open up our game manager. What did I just say I was going to do? I was going to add turns. Can't remember whether I made black 0 or 1 for the piece color, but I think black is 0 and white is 1. So, global dot turn equals 0. All right, so now what we're going to do is say you cannot pick up a piece unless it is your turn. So we'll put that into here. Turn equals team. So now only the black pieces should be able to be picked up. Oh, well. Okay, only the white pieces are able to be picked up. What I definitely said. So white is 0, black is 1. So now what we want to do, want to make it so whose turn it is switches if you put down a piece, but only if the piece has been set down somewhere different to where it was originally. So okay. So we will take this code because the board position should, no, wait, the board position will update every frame even when we're carrying the piece. That's interesting. I think that does not need to be the case. So I will try changing that. Actually, before I even do anything with this, I'm going to move this into when a piece is set down. And just see, I guess you can't really see the board positions, but you know, if that's a problem, it'll be obvious later. I'll just add a little note. And then okay, so that, and then oops. Okay. And then turn modulo 1. I think that's right. It might be modulo 2, but I think it's modulo 1. We'll just give it a shot. Okay, so you can only pick up the white pieces. Place it down. You can still pick it up. Okay, so that did not go as planned. So should it be modulo 2 then? I can't remember whether you include Okay, that's obviously not. Oh, yep, there we go. Okay, that's there is the explanation. All right, now this should run as intended. Pick up the white piece. We can still pick up the white piece and not the black piece. Okay. Now we will make it modulo 2. So as you guys can see, I'm actually quite bad at math for a programmer. I just... Uh, that still doesn't work. Hmm. How do you print in this? It's... Uh, sorry, I've been doing Java recently for Minecraft mods. Uh, it's... no, I can't remember it. It is... Uh, show debug message. Oh, am I checking turn? I think I know what's happening here. I'm not checking the global... No, I am. Okay, well, we're going to run this and see what happens. So, pick it up and place it down. This code is not being run. Okay, so now it's a math issue. Okay, so now if you pick up a piece and place it down anywhere that is not the position you picked it up from, then it goes to the next person's turn. So there's our turn system. That was pretty fast. Okay. Let's see. Now I think we go into move legality. So this is going to have some exceptions. And I almost wonder if it's faster to program in the exceptions to this first or to program in everything else first. Because this is not true if you are castling. And I think that's the only exception, but it'd also be nice to have a user interface that lets you turn on and off, like en passant. And that's it, really, just en passant. But hmm, yeah, it would be fun to make this a data-driven game, you know? So like maybe there's just like a file that you can change like when the game is already compiled that's like how all of the different pieces move. I think that's starting to really breach like beyond the scope of this project, but maybe I'll do it after I finish it the way that it is. So, the moment you can move a piece in any direction. Um, let's just start by, okay, we want to have a green tile that shows up to indicate spaces where you can move. So, no, that's right. 20, height 1080, like that, 32 by 32, okay. Uh, okay. All right, now we can go ahead and import the sprite for that. So the legality checker, I think, will run every time that you pick up a piece. And then the object for the green tiles can hold the code for like, or like maybe you can only place it down on a green tile. I think that sounds good to me. So we're going to go ahead and create a new sprite. All right, we'll import green tile. Okay. Now we'll create the object for it. And I'm not doing any draw GUI stuff because I also want this to be able to be done in limited 3D. Like I could just flip a switch and then make some tweaks. For now, we will just assign it this sprite, and that might be the only thing we need to do with this object. Uh, at some point, I may make a lighter and darker green space variant to indicate which color the tile underneath is, just for the sake of, you know, being user friendly. Okay, so how's this going to work? We will check every board position. Okay, we are going to pass an empty array. I'm going to take out this part of the code for a bit. And then with every piece object, all of this I think is going to go, but I'm not going to comment it out until I've moved where the legality checker is called. So the upright push positions. I guess actually we'll call it pieces. Because it's holding the actual ID and not the position. Okay, here's the question. Is it faster to pass it a list of every position and then check that list, or is it faster? I think it's faster to just actually check like this. Or is it? It's not. It's not, because we're going to pass. Okay, I was onto something the first time with the positions. So now we've passed in all of the piece objects have passed in their X and Y positions and their team. And now we don't have to check all of them concurrently. Or like, I guess it's not exactly concurrently this way, but we check them sequentially and we go through the list starting from the first entry going down, and we can just stop when we find it, when we find the position like of, because we'll do this for every board position. Oh, no. And we actually won't end up doing this for every board position in the final product, only for potentially legal moves. So I'm actually going to just take all this out for now and start working on just drawing green tiles wherever the piece can move naturally, ignoring any, like, the positions of any other pieces. So the first thing we do is just code in placing green tiles anywhere that the pawn can move. So that is um, okay. So what is pre-x and pre-y? Is this telling us, yeah, this is telling us where the piece will walk to. So instance create layer pre-x, pre-y plus 1, or not plus 1, plus 32. Let's make a new instance layer that's just for the, yeah, that works fine. Okay, we'll make a new instance layer that is just for the green tiles to go on. Space. And then do we require, I don't think we require struct, so now when we, I think, place down upon, okay, so it's only, right, it only works correctly for the black team. I was only thinking about the black team. Otherwise, this is working as expected, even if that expected behavior is not technically correct. So now when we place down the pawn, it should show us a legal movement. It is not. Okay. Yes, this is working correctly. So obviously this is not the intended behavior. We want the, okay, so we're gonna go ahead and take this code. We're basically overhauling how this method works now. So we take away we're not going to need any of these to be vars anymore. Well, I guess. And then I think this will interact with okay. Let's give this a whirl. All right, now it is not being placed down because I have removed the ability for the legality checker to mark a move as valid. So instead, we're going to say if instance exists, okay. Okay. Now that is done, and we will run the legality checker when the piece is picked up. Uh, it's EXY, that's right. Okay, now let's run the code and see what happens. That we can only place it where there is a valid tile. As you can see, there is still some strangeness to this. You know, I can go ahead and just place this on a tile that was created in somebody else's move. So we will just go ahead and destroy Actually, no, we don't just destroy the one that we actually use. We destroy all of them. Instance destroy. Uh, will this destroy all of them? That's the real question. Well, at the moment, we are only placing one anyways, so there's no way to know. Uh, However, if we program in the en passant rule, then there will be an instance in which we can do two without ever actually leaving the pawn. Uh, so this is for the white team. Their starting Y position for a pawn should be 32. Uh, okay, now for white, there are two, and they're both destroyed. Great. So now we just have to program in en passant for uh, the black team. So we'll just copy this code. Uh, their pre-Y should be let's see, what would it be? Be 8 times 7 times 32, I think. So we'll just should be 224. And now I'm not sure if that is actually for the lowest layer or for the layer that the pawns are on. So we will just find out. Okay, and now that also did not do anything. Okay. This did not seem to work. I don't really know why, honestly. Uh, okay, that did it. And as you can see, we can move them all the way up to the second position on the first turn. Uh, that's not en passant rule, that's right. En passant is something like going diagonally behind a pawn to take it. I'm going to have to look it up. So I definitely do not remember what that rule is. Anyways, that is looking good. Now, what needs to be done is to check for pieces that occupy a space where we are trying to place a tile. So in this case, we're going to get the positions of every piece on the board. All right. Now I still think this is faster than checking every piece for every time we try to draw a tile, because we only have to check them all once. Does this not have 4 loops? Where can Gamemaker? Oh, no, it was this one that was the problem. All right. Not H. That return code is what makes this method faster. Um, honestly, you might be able to use return codes in with, but I'm not really sure, and I know you can do it in for. Uh, honestly, I should look into whether you can do it in with, because if you can, that would actually be faster. You know what, let's just try it. Uh, with piece object, if no, we need to make valid of bar. Okay. Yeah, so can we just return from here? Ah, there we go. Now this pawn has no legal moves. All right, so that's looking good so far. Just gonna go ahead and take out the whole for code. Wait a second. Is return taking us out of the whole script? Return is taking us out of the whole script, which is not what we want it to do. So I guess we just have to accept the unoptimization, I suppose, of the code. Well, that's not working. Yeah, this is not working. It's not marking moves as invalid like it's supposed to. Let's just see if that ever happens. Oh, what? It worked that time. Is it because I've not done it right on the other one? Wait, is this? Oh, this is also confined to one team. I did not realize that. All right. Yep, now the piece has no legal moves. This does lead to a soft block, so now let's fix that. Um, hmm. This does not work as intended. Something wrong with this code. Okay. What we need to do is to store the last place that the piece was on the board. Uh, all of this monstrosity can go away. All right. Now, hopefully, we can place a piece down in the same position we picked it up from. We cannot. Oh, right, because we should be looking at. Okay, now we can pick up a piece, set it back down. Does not progress to the other player's turn. Let's see if it works for you. Yes, it does. Okay, now we just place the piece back down where it came from. Okay, I think we need some kind of visual indicator of that. So we will make it yellow. All right, now we can import the sprite. And this sprite will be drawn. Okay, so now we actually don't need the last x and last y variables, because we will just draw the sprite. Or, well, actually, we need an object. Oops, I didn't know you could do that. We'll put this in the legality checker. Starting space, and that should do it. Now we just need to I'm not too worried about checking that this instance exists because one will always be created when you pick up a piece, and you have to have a piece picked up for this code to run. So I am not going to worry about that. All right. There we go. Now there's a nice little visual indicator. And it works on this side as well. And as you can see here, only legal move is onto the yellow space. Now there's still some stuff that has to be done, like, hey, this is not the only legal move for this pawn. It should be able to attack this pawn. That we will do now, I think. I think just doing everything for the pawns first makes the most sense. And wow, this is a lot of code. This is going to end up being a really long script, and I'm wondering if maybe I should split it into multiples. Nah, that would be too much work. Okay. Now we need to make a version of this for checking if you can take a piece. So we'll put that at the very beginning here. If x equals, this is for black team is 1. This is for black team. So that is plus 32 on both. Or is it? It's minus 32, I think. We're just going to copy this code because that is easier. I'm just going to change how I formatted this for consistency. All right, now let's run this, and now the black team should be able to take pieces. That's not right. What piece are you seeing? Okay, so this, it works correctly. It does not take the piece. We will pass now that won't be done in here. That'll be done. We might have another method for taking pieces. Okay. So we saw this did not work correctly. It's seeing it's seeing something it should not see. It's actually always seeing every single time without fail. It sees something there, even if there is nothing there. Oh, and that is because wait, sorry, I did that to the wrong one. Valid is always preset to true. And after this, oh, hey, this isn't where it's supposed to be. Now valid will be preset to false for this one, or is it should be true now? This is not right either. That also went somewhere it's not supposed to go. Valid equals. Okay, that it seems to work now for the black team, which like I said is the only one capable of taking pieces at the moment. So we're going to grab all this code and give it to the else method um, and swap out the pluses for minuses. And then we should also make it check if it is the opposite team. So do we have, we do have an underscore team. All right, so we'll just take that and slap it on here. Wait, I put it in the wrong one again. All right, now we run the code. Now we can only take pieces of the opposite team. Should have no noticeable difference. Okay, it does not work. It does not work for the white team, which is not ideal. What's different? That's the question. Yeah, it just doesn't work for the white team. The question is why? Uh, this one, this is the white team's code, right? There's the white team's code down there. I really need to note this. Okay. Okay, so it works for team one, which is the black team. Uh, well, it does. Wait, what? Why is it saying created for team one? Okay, I'm really confused. Did I not change it to 0? I didn't change it to 0. This is very odd. It's only checking in one direction. That's what it is. Okay. Okay, so now I think it might make it on the wrong spot sometimes. Well, it works like this. Uh, yeah, that was completely wrong. So we'll have to look into that one. Oh, that's because I should have done this to X, not Y. That was a rookie mistake. Wait, that's not right. Okay, now we need a separate variable to denote which side the thing is going to appear on. First, let me actually just put it like, wait, that's not right at all. Yeah, no, we need a separate variable. Uh, hmm. There can be instances where you could do both. So All right, so we'll do it on this team first, which I think is the white team. I really need to write this down next time I look. Okay. Okay. Actually, valid does not need to be involved in this. And then we will just copy this code and swap it to minus 32, and then it will be minus x. Okay, now we once again copy this code and it's minus x, and we do minus 32. Okay, I don't remember which team this will be for, but it'll be for one of them. Ah, it really doesn't work. So it's seeing opponents here and here. It's because we are setting it to true at the start. And then we need to reset it after this. I don't think we actually do need to, but I'm not confident on that, so I'm going to do it anyways. I only did one of them. Okay. Take two. Here it doesn't see it at all. There we go. I'm going to move a different piece so we can. Bam! Look at that! It sees both of them. It sees both of these. Okay. Now can it see just one? It sure can. Can it see just the other one? Yes, it can. Great. Okay. So it's working perfectly for the one team. Now we will copy this code over. There we go, guys. I finally did it. I finally took a note. Okay. Let me put a note on this one. And then I will run the code, and then it will work perfectly, and no errors will happen. Okay, so it sees the one. It sees two. And it sees just the left as well. Okay, so it looks great. It looks like everything is working fine. Wait, was I wrong? Is black 1 and white 2? I'm just going to take this note out just in case I'm wrong. Okay. Yeah, we're making some really good progress. Now let's test out picking up pieces that are not pawns. Yep, right now it shows where I picked them up from, and that's it. That is as expected. Now here is an interesting test I can do for this. Okay, so we're gonna move you to here, move you to here, take this one. Right, there's that. I still haven't programmed in taking pieces. So I actually think that should be the next bit. Uh, okay. This exists. Well, we don't need to check that. Piece object. Um, uh, okay. I think you can pass no arguments to instance destroy. Okay. Now we should be able to take pieces. It worked. It worked. Let me just, yeah, the piece is gone. It's dead. At some point, we will move the pieces to be off the board on the side of the player who took them. Uh, Now, theoretically, you can take your own pieces, but I think in practice that should never actually be possible because it won't count that as a valid move space if your piece is there. Now, I do want to see, will it try to take my own piece from this side? And it will not. This one won't either, but it, oh, right, I was going to say I can't see the space right in front of it. I got confused because of how the color changes when you hover it, which is a sign that maybe that mechanic should be tweaked. Uh, yeah, that definitely will need to be changed. Um, and then I am wondering if a piece can be blocked by another piece of its own team. It will not let me. Oh, right, it's not my turn. Okay, yes, it can. It can be blocked by another piece of its own team. I think everything is in order with the pawns except for the en passant rule, so I actually got to look up how that works real quick. Okay. This is actually going to be pretty hard to program in. Uh, so essentially, how en passant works, um, if, for example, say white team is the one attacking. If black has a pawn at the starting line and it moves forward 2 spaces, and white has a pawn that could have taken the black pawn if it only moved forward 1 space on the first turn, then I already forgot which team was attacking, but I think it was white was attacking. Then white can move diagonally behind the black pawn that just moved forward 2 spaces, only if it just did that move on black's previous turn, like right before this. It can move diagonally and it will take the pawn as though the pawn had only moved 1 space on its first turn. Uh, so that is how en passant works, and it's going to be hard to program because yeah, we need like a whole new variable that pieces will have um, that says if they're um, oh, if they just moved, like if the previous turn was their first turn moving, because it shouldn't work if the pawn moved up 1 space twice. It also shouldn't work if the pawn moved forward the 2 spaces, but that wasn't just the previous turn. Uh, so I don't know how actually like I don't know how to achieve this in an optimal way. Uh, I think really it's just going to be we're going to give an underscore move 2 on last turn, or a variable to piece object. Okay, so this should only ever be true if the piece is a pawn and on it's on the player's previous turn it moved forward. So when the turn updates, okay, let's just add a global turn counter to the game. That's probably going to be the easiest way to achieve this. All right. Yeah, we're actually going to change this variable so it tells us to on turn, and then that will be updated with the turn on which a pawn moved forward by 2 pieces, by 2 places, if such a thing happened. Uh, so this will go into the step function. Anytime that the turn flips, turn. Actually, I think we can. Does plus plus work in Gamemaker language? I think it does. So that can actually be done. Now, does white still move first? White still moves first. Then black, then white. I cannot. Okay. Yeah, it looks like I did not break anything by doing that. Yeah, everything looks all good. Okay. Uh, okay. So now the turn counter should just increase every time that move is made. I don't know if there's normally any kind of turn counting in chess, if that's used in like stalemate situations or anything. I don't know. I'm a Pokemon player, but I don't think such a thing exists. I think maybe when I get closer to the end of writing this engine, I can get like a pro chess player to look over this. Just find someone on Twitter with open DMs and ask them to, try all the weird things they can think of and see if it breaks the game. Uh, Otherwise, I can always just do a lot of reading on Wikipedia, probably. Or, like, I have a couple books on chess that I could read as well. I've been interested in chess for a very long time. I've just never been that knowledgeable about it. I probably know slightly more than the average person about chess, but still less than might be necessary to make a comprehensive chess engine. So, whatever way I have to compensate for that, I'll get it done. Um, okay, so in the step function, um, when we place the piece, where does this happen? Right here. Okay, if uh, type equals pawn and uh, 3x equals starting space x plus hmm, uh, okay, we're gonna do one for each team. And 3y equals starting space dot. Okay, actually, I'm changing how we're doing this. Adding a has moved variable equals false. And then when a piece moves, that variable will be updated. It's moved true because I think that's relevant for stuff like castling as well. Just the other weird rules in chess. I do love castling though. I think it's neat. That was always my favorite thing when I was a kid. I would always, always, always just play to castle my king as early as possible. Is it optimal? Definitely not, but that's what I always did. I, okay, plus 64, right, has moved equals false, and well, actually, this one can go outside of here. Um, and for this should be team and not team, and then okay, so which one is team and which one is not team? I want to say that white is 1, black is 2, or 0. I mean, I think that's correct. White is on the player's side, so 3x equals what would be, I think it's 3y equals 92, and 3y equals 64. Then 2 turn equals turn global dot turn counter. All right, and then we're gonna go ahead and show debug message for this. Um, move 2, then we'll copy and paste this code. Wait, never mind, we don't need to do that because we're already checking both teams. All right. That did not work. That also did not work. So we're going to try flipping team and not team and see if that fixes it. That did not fix it. Okay, something is wrong. Which of these conditions is not being met? That is the question. Where are we drawing these extra Okay. 192 and 64 are the starting positions. So actually, 128 and 2 minus 64 is 128. Wait, what? That's not right. Whatever. We'll see which one works. Okay. It was white that worked, which I think is team. So we're gonna. Do we add 32 to this? Or do we subtract it? I think probably. Okay. Okay, so this means that not team or team 0 is white. And that we then need to this 96. Now it should work. Okay. Looks good. Uh, okay. That's just a little thing. Code should run the same. Yeah. Okay. Looks good to me. Now, how do I feel about making the scale to arbitrary board size? Uh, the answer is why not include the code just in case? Okay, now we run that. I think I might have gotten it backwards. I did get it backwards. Okay, that did not work. Yep, I'm just not going to worry about scaling to arbitrary board sizes right now. That's something I decide I want to do later. Boy, I broke the code. Oh, wait, no, I didn't. Sorry. This looks like it actually may have worked. And we're just going to go ahead and Okay, that looks good then. Okay, now it's time to add en passant. Okay, I want to do arbitrary board size, future proofing, basically. So if you're like, hey, it would be fun, 12 by 8 chess, then, okay, whatever. Um, I don't know if there's any real purpose to doing this, but, I'd rather just set up a system that is flexible to that sort of thing, just in case it comes up. And this global dot tile size, uh, that tells us how big one tile is. So if I want to change the scaling, say I want a tile to be 16 pixels instead, or 128 pixels instead, that doesn't just break the game. I think this will break this code, but I will just fix it. Okay, let's run this and see if it broke anything. Yep, it looks like everything still works fine. No strange happenings to report. Okay. Now we will look for 4, because I know that happened at least a couple times. 2 times global dot tile size. Okay. Once again, we save and we run the code. Once again, it seems nothing is broken. This here, what I'm looking at now in the piece object step event 59, that is relative to the tile size. So I will update that manually in 1 second. Uh, all right. not sure I'm ever actually using the board position anywhere. It might be something that gets written out later. Oh, never mind. I'm using it in here, and I'm using it quite a lot. All right. Let's run this. Looks like that worked all right. I'm not going to mess with the X anywhere. Yep, everything works just fine. I know this might be a little bit boring, but this is all board X. Here's one. Okay, now in here, we're gonna I don't want to have to reference that every time. So TS8, TS minus TS over 8, TS over 8, TS minus TS over 8. All right, now it's not debug mode. Now we run the code, and it seems like the hovering still works basically the same. Yep, okay. Everything looks fine now. The only difference is that now, if we wanted to make the board way taller, you know, we could just change it in here and then update the board dimensions. I'm not going to do anything with different board X dimensions because that would require me to make arbitrary decisions about how the game would work when scaled up to that size. Like, are the pieces split down the middle and then put on each side? Do you get repeat pieces to fill out the board? Is there an equal amount of space between every piece? What do you do if it doesn't divide up equally? All just stuff I don't want to deal with. So I'm going to leave that be, but, if other people want to do stuff with that, I'm thinking I'll probably release the source code for this on my GitHub. If other people want to mod it, that's how you'll do that, is by just editing the board dimensions X value, and then however you want to do your piece distribution, you'll just do out of the create event of the piece object. These variables are not being used anymore. All right. So our code's looking quite clean now. Still have not implemented the en passant rule. So that shall be the next thing we do. Um, Depending on how long that takes, I might just end stream after that. My back's starting to hurt. I don't got the best seating position. But, we'll just see. All right. We're going to go into the legality checker. And on the slot, we'll just go right up here with piece object. If equals pawn. This probably could have been done more resource efficiently. If that's the whole story. It could have been done more resource efficiently if I had made all the different pieces be like a child of the piece object, but I like the way that I've got things going now. So I'm not going to change that. I like having it automate which piece becomes which type rather than having to manually lay them out in the room editor. And the downside of that is that we will scan every piece object instead of just the pawns when we're doing this. So type equals pawn, and moved to on turn equals global dot turn counter minus 1. Then in here we will check if well, actually, we don't need to check if it's the opposite team because your team will never move 2 turns in a row. 3x equals team equals. No, because we're already determining this. This is the team we're working with. So we're working with white team. White team moves up the board, so that's minus y. Pre-x plus tile size we're going to be using the plus and minus x again. Equals x and well. Hey, wait a second. This is very redundant code. I'll fix that in a second. I think it actually should be minus for this one. It's plus on here. So I'm going to make it plus and we'll just see what happens. Plus x equals true. What's unfortunate, I think, is that we're going to have to run this whole check over again when we actually play the piece, and I don't know if there's a way to avoid that, so I'm not going to try. X minus global dot tile size equals x. Then, we need underscores in front of all of these. I can't believe I didn't notice that sooner. x equals true. All right. Wait, why do I now have... Okay. And this condition. Take out this excess if statement. As I've said before, I am very anal about optimizing my code as much as possible. Yeah, and I use the double equals again here. Okay. Now with this out of the way, I think the code for this should more or less be the same, actually. Right? Because... Oh, hey, wait a second. We only check if they're on the same Y position. Right? Because you move past, you start on the same position, and then you move diagonally past them. Okay. Yep, let's go ahead and run this. So we'll just have two pawns walk up opposite. Oh, thanks. So I guess it's black. That is team one. It makes sense because team zero goes first. Well, I screwed this up. I'll just then, okay, the tile does not appear. That's a white piece, though. I just said black is team one. Well, that's not right either. Okay. Bam. 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 Hey, look at that! It works! Okay, that's awesome. Okay, now we will reset and test if it works the other way. So if the white piece is on the right, and it once again works. Okay, that's awesome. Now we just need to destroy that piece. Well, actually, first we need to make it work on the other team. Let's not get ahead of myself. Oops. Okay, and then we need to also plus x equals false, or minus equals false, right? That's what they're defaulted to. That's correct. Okay, so we'll add that to the other one as well. Okay, now we will go back down here. Okay, now we will run the code and see if white is now capable of performing an en passant. Hey, that's not right. Okay. Well, it works, but at what cost? Because we saw something very wrong on the very first turn. Why did that happen? Oh, because, okay. Very interesting, very interesting. If you guys don't catch this, this is happening because when we create the piece object, we say move 2 on turn equals -1 as an indicator that it has not, happened, right? Because 0 is an actual turn. But because we're checking if it happened on the previous turn, and the previous turn before 0 is -1, then it returns true for both of the pawns right next to the white piece. So if we just update that to -2, then everything should work as normal. All right, and I screwed it up again. Hang on. Okay, now we can en passant. Looks good, looks good. Did it to the right. Now let's do it to the left. Okay, that's perfect. Now all we need to do is to destroy the pieces. Okay, type equals pawn, and moved to on turn equals local dot turn counter -1, and y equals, no, x equals 3x, and y. Okay, now we do separate team stuff. That is not right. Is there an underscore team variable? There's not. That's fine, we'll just do that. X equals pre-x, and then y. Okay. Team 1, which is black. So if it's black and the piece is at, the piece that en passanted it is at a lower y position, because white moves up the board, which is -y. Uh, okay, so there's that for the white team. Or, well, I guess for when the attacker is on the white team, that is. And then for when the attacker is on the black team. Oops. Now, is there still an error? Oh, because I did nothing in the... Technically, I think this could be condensed down into... Actually, I think this should be condensed down into one if statement, which is going to look really gross, but that is optimal. Because that way, if it's already destroyed, well, I guess it would never run the code if the instance was already destroyed anyways, but whatever, I already changed it. Okay. All right, look at that. That worked on the left side from the white team. Now we will try the right side from the white team. Okay, looks good. Now we can try the left side from the black team. It did not work. Let's find out why that did not work. Right, because one of these should be not team. Not positive which one it is. I think the second one. So we will try again with white. Not that piece. Okay, worked on the left. Let's actually test black team now. Worked on the right. Okay. And then this one works on the right. And this one works on the left. Okay. We also need to check if okay, so now it only works with pawns. Good catch, me. And now our Passant method is complete, which is probably the second most complicated thing that we will program in this. Maybe the first if you consider that the framework was not there yet. Obviously, the first would be castling, but now that we've built some of the framework for En Passant, then castling will be a bit easier because we've already established a system of like counting turns and stuff like that, determining whether or not a piece is already moved. So trying to think if I want to do anything else before I get off, or if I'd rather just stop now. I don't know. It's hard because, like I said on the last stream, I get so into programming when I'm doing it that like it's hard to make myself stop. However, I do think it would be wise for me to get myself a bit of food soon. Maybe find a more comfortable place to sit because as it stands, you know, I can only stream from my bedroom and there's not really a comfortable seating space in here. So I think let's go over what we're going to do next time, at the very least, before I get going. I think next we are going to start programming the movement of other pieces, probably starting with the king, because the king's movement is pretty simple, and also programming in the king's movement will lead directly to programming castling. If I remember correctly, that is, maybe it's the rook that initiates a castle. You know, I'll look into that before the next stream, whether it's the rook or the king that initiates a castle, because I have not played chess in a while. And then you know, just go from there. Probably, hopefully, now that I've done all of this once for the pawns, you know, well, actually, this script for the pawns, 175 lines of code, and at the moment it only manages pawns. Brilliant. Yeah, I'll move into either king or rook movement next time, depending on which one is necessary for castling. I want to start like from highest to lowest complexity. just because starting with the pawns makes the most sense because you don't need another piece to move for your pawn to be able to move, and they're the most complex piece in terms of behavior because they attack diagonally, move normally forwards, and have the capability of moving 2 on the first turn and the en passant. There's a lot of different, very unique functions for one piece to have. Then probably next most complex is either the rook or the king, just depending on which one is needed to initiate castling. Maybe both are. Programming in stalemates and game overs will probably be like the last thing I do. So that won't be part of like programming king behavior. Queen is definitely the least complex piece that I will have to program, because then the bishop, I guess for all of them, we're going to have to limit the ability to go past the edge of the board. So probably the bishop is the least complex, then the queen, then the right, bishop, and then queen, and then either king or rook, depending on which one is not actually need to move for castling. Those would probably be below queen. And then the knight and then the pawn. And the knight could also even be less complex, considering that it just ignores pieces like on its path. I don't know. The knight's a weird piece, and I think it's going to take some trial and error to get that one working. So I'll look into castling. Next time we'll do whichever pieces are necessary for castling. We'll program in castling, and then we will do knights. That'll probably be on the same stream, but it might be a separate stream. And then after that, I anticipate all of the remaining pieces we can tackle in one stream, maybe two. So yeah, I think we've got 2 to 3 more streams ahead of us for this project, and that is not counting. No, we definitely have 3 more ahead of us because we also need to program in like game over scenarios. And then a break, I will do a stream of developing a combat engine for the RPG that Coalition is working on. Again, if you are interested, please do check out the Coalition Twitter and YouTube. And, you know, subscribe and turn on notifications to get notified when I do that stream and the future chess streams. After I do that, then we will come back and do chess AI. And in terms of programming streams, that's all I've got in mind at the moment. But I can promise you I will do more programming streams because I've had a lot of fun doing the chess stream, you know. And it's not even so much, to go on a little bit of a tangent here, if you're here for the programming, now's the time that you click off the video, but this will only be a minute or two. The thing about programming that can be difficult for me is that I find it very difficult as somebody who has ADHD to regulate all of my sensory needs and to maintain focus for a long time while programming. Programming is particularly difficult for that because the computer is a distracting environment, you know, and you know, I get really excited when I figure out why an issue is happening and I figure out how to fix it, and then I want to talk about it. And usually there's nobody around me who like I can talk to about it. So doing this on stream has given me the opportunity to do that, even if there's nobody here, you know, actively listening. Just kind of the idea of being able to express, you know, what I'm thinking about to my, you know, vacant audience, and, you know, for potentially somebody to find it who finds it interesting in the future after the VODs are done. and then being held accountable, to keep working. If I'm like, I want to do a stream for at least 2 hours of programming, um, I can hold myself accountable if I'm doing the stream. I've got like, this stream is evidence that I did or did not achieve what I was setting out to do. And so therefore it gives me that extra push of motivation to stay focused and stay doing what I want to be doing and really persist through problems that otherwise may make me just want to give up. Um, so with all of that being said, you can definitely expect more programming streams in the future outside of just the 2 series that I have planned so far. Um, but those 2 series probably gonna, take a while to finish anyways. Like, I think that like 3 more streams for chess without the AI, I would bet a lot of streams for chess AI alone, like as many as potentially the entire game without the AI takes to make. Um, and then for the Coalition combat engine, I would peg it at 6 to 7 streams, maybe a bit more because there'll be some game design elements in there too. Stuff that I'll be figuring out and rebalancing and tweaking on the stream instead of just programming a game that already exists. So yeah, 6 to 7 to 8 maybe for that. Probably like 5 for chess AI, and that's a good, healthy like 15 streams ahead of us, like 2 hours each of just these 2 projects. So, once that is all said and done, I'll figure out what I'm going to do next. Maybe I'll figure it out along the way. Who knows? But if you have any ideas for what you want to see, um, just leave it in the comments. I'm thinking maybe like a DDR or Friday Night Funkin' style rhythm game. I do worry that might be a little bit on the simple side and wouldn't take as long to finish. So yeah, if you have ideas, leave them in the comments. Thanks for watching, and make sure to subscribe and turn on notifications to be notified when I go live next.